All right, guys, it is time for part 2 of lesson 4, powers of monomials. And part 2 is going to focus on power of a product. Yeah, I made a typo there. All right, so power of a product, property. And you can pause and copy down the words that describe this property. It says, to find the power of a product, find the power of each of the factors. I'm going to give you an example to get us started. Let's say we have 6x to the third, and that whole product there, it's a product because it's two things being multiplied, a 6 times an x to the third. That makes it a product, and we're taking that to a power. So we're going to have an exponent on the outside. Now, this says that we have to look at this as, well, this power on the outside, the 2, says that we're going to use everything in the parentheses twice. All right, so we're going to do the 6 twice. And remember from part 1 of this lesson, what do we do when we take a power to a power? So x to the third to the second, what do we do with the exponents? We keep the base and we multiply those exponents. All right, so then now we can simplify. So the 6 squared is going to be 36, and the x to the third times 2 is going to be x to the 6th. All right, so we take that 2 to both of the factors in that product. Now let's look at some algebra here. Let's say we have a product. Let's call it a times b, and the b has an n for an exponent, and on the outside we have an m. All right, that m has to be taken to the first factor and to the second factor. So we get a to the m. And then what happens with that n and the m? Right? A power to a power rule says we multiply the exponents. So we get a to the m, b to the nm. All right? There we go. So that's the general product. Now, the general property. Now we're going to see kind of why it works. Just expand a little bit, talk to you a little bit about it. Hopefully it sinks in why it works. That helps me. It helps me remember the properties when I know why that property works the way it does. So we're going to look at this example here. We got that 3. What does that tell us to do? It tells us to take everything in these parentheses 3 times. So that's 4x squared times 4x squared times 4x squared. All right, so now we can use commutative property because we notice that we have a bunch of factors. No other operation but multiplication. So we're going to take these numbers and group the 4's together. We got 3 of those, and we got our 3x squareds. Excuse me. And so basically that 3 makes us have 4 3's, right? 4 to the third. And it makes us have 3 groups of 2 x's, right? Because there's 2 x's here, 2 x's here, 2 x's here. And so how many x's would that be in all? Right? 3 groups of 2. So we get x to the 6th. All right, so now we can take that guy and simplify him. All right, 4 times 4 is 16 times 4 is 64. And then we have the x to the 6th. All right, so this is equal to this, which is equal to this, which is essentially equal to the original problem we started with. And this down at the bottom is our most simplified form. All right, so that 3 outside made us have 3 of all the factors inside those parentheses. Now, let's practice this a little bit. You can pause, try it, see what you get, and then come back and check it out, see if you are the same, if you get the same answer as I did. Now, we're back. So, we need all of the factors inside those parentheses to be taken to the 4th power. So we need to take 4 to the 4th and p to the third to the 4th. And what's the property there when we take a power to a power? We simply multiply the exponents. Keep the base, multiply the exponents. Now, 4 to the 4th, yikes. We're going to simplify this. So that's going to be 256, and then p to the 12th. All right, now we're going to put the justification or the rules and properties that we use, we're going to put those off to the right. All right, this is a good format to be in the habit of using, where you have the original problem here, you put an equal sign and move right to the right with this first part, and then we move down and simplify downward. All right, so what was the property? What do we call that property that we used right there? We call it the power of a product property. So, right, that explains what we did on that first step. Then we explain what we did on this next step from here to here. All right, all we did was we did some of the operations to simplify this. All right, so those are our two things that we did. We did the power of products property, and then we simplified. Let's try this next one. Good one to practice because of this negative sign here, that negative right there. Remember, with powers, it's important to put any of the negative factors into parentheses because that can mess us up. All right, we're going to start by using our property, and we're going to take it, that 5, to all these factors inside. This is different than the ones we've done previously because we have 1, 2, 3 factors in that group. So we take the -2 to the 5th. Notice I put the -2 in parentheses. Then we have the m to the 7th to the 5th. Power to a power, so we multiply those exponents. And then we have n to the 6th to the 5th. So that'd be 6 times 5. Now we're going to simplify. Looking at the -2 to the 5th, I know that it's an odd power. 5 is odd, so I know I'm getting a negative. Now I just have to figure out what 2 times 2 times 2 times 2 times 2 is. And that's going to be 32. So we get -32 when we simplify that. Then we get m to the 35th and n to the 30th. And now I'm going to quickly write down the steps that I took to accomplish that. I know that this was the power of a product. Oops. And then we just did the actual operation right here. And when we do an operation, we call it simplifying. So simplify. All right, now it's your turn. Show me what you got. Try these 3. Pause it, try these 3, and then when you're done, see how you did. All right, we're back. And let's check it out. We have to kind of like distribute. I don't want to use that word because it's not officially what this is, but we have to take that 2 outside the parentheses to both of the factors inside. We get 8 squared, and we get b to the 9 to the 2nd, and that gives us 64b to the 18th. Next, we have to take this 4 on the outside to each of the factors inside, and we get 6 to the 4th, x to the 5 times 4, and y to the 11 times 4. And moving on, 6 to the 4th, 1,296. That'd be x to the 20th, y to the 44th. Wow. All right, I'm going to expand mine a little bit so I have a little more room to work here. I have the -3, -5 to the 3rd, w to the 2nd to the 3rd, and z to the 8th to the 3rd. Make sure you put those negative numbers in parentheses. Get in that habit. Then we have the w to the 2nd to the 3rd. We're going to multiply those powers, and z to the 8th to the 3rd. And now we simplify. So when we do a negative to an odd power, we get a negative. 5 times 5 times 5 is 125. We have w to the 2 times 3, so that's w to the 6. Z to the 8 times 3, which is 24. Boom. How'd you do? Thumbs up. Give yourself a pat on the back if you got 3 for 3. If not, figure out where you made your mistake, then learn from it. Then pat yourself on the back because you're persevering, and that's awesome. All right, hopefully you do well on your work and that this is not too bad for you. Good luck.